Thank you for inviting me. We are going to talk about batteries, and I have some experience of working on a particular class of battery applications. We, of course, electrical engineers, when we go to our first year electrical circuits class, the first thing we learn is a battery. But interestingly, we probably don't learn enough even when we graduate. A battery is a very complex device, and the kind of exposures that and I don't think we give enough exposure to our electrical engineering students to batteries. Anyway, the point that I would like to make is that electric mobility is a very important application of batteries, and it is a very popular thing. You hear about it in the social media a lot. So we will, but still, I would argue that in spite of all the interest and enthusiasm, enough is not happening in the electric mobility scenario. We will try to look into why it is not happening, and we'll see that the battery plays a very important role there. But more importantly, we'll see that if we, cross these hurdles, because we do have to cross them. It's interesting to see that basically a spectrum of technologies are required to have people buy electric cars. I bought a car about 2 weeks back. I am an electric car researcher. I didn't buy an electric car, and there are reasons for it. But there are things that can be done about it. So that's the essential topic of the lecture. So I thank you for the opportunity of sharing my thoughts, and I always like to acknowledge whatever I'm going to speak of. I have learned from my colleagues and my students, and of course my sponsors. So basically, we need electric mobility for three major reasons. The first is that we need less carbon emission, and in our country, when we burn electricity, we do produce carbon. That's global. We need local air pollution to be managed. Air pollution is really a concern. And the third is that we don't produce oil. We actually spent a lot of national resource trying to buy oil. So these are the three major reasons why we absolutely need electric transportation in India. There are various advantages and disadvantages. It's beautiful actually. If you have ridden an electric vehicle, a four-wheeler, something like Tata Nexon, it's a pleasure. It's somewhat dangerous as well. It's very silent. It can accelerate very fast. It's very nice to ride it. But there are some major disadvantages. And some of these disadvantages are that we have short range. In any normal car you buy, you have something like 400 kilometers of range easily. More than that, actually 500 is more like a figure, 500-600. Here we have, depending on the money you are willing to spend, maybe 200, maybe less. Charging is slow, cars are expensive, so there are lots of reasons, and we'll look at them in some details, and that's one of the stumbling blocks. See, where electric vehicle sales is happening at 2 points. It's happening at two-wheelers and three-wheelers, and it's also happening at the bus range. At the bus range, it's generally public money which is being spent. The governments are buying the buses, and at the low range, people are buying electric scooters. But in the four-wheeler range or in the pickup van range, we are not seeing enough electric vehicles. That's the problem that we are going to talk about. Let's see what we mean by an electric vehicle. So we know what is a conventional vehicle, and do we have? Can you see my mouse? So in a conventional vehicle, you have an engine which is coupled through a transmission to the wheels. And in electric vehicles, you have that. You could have an engine. Previously, people used to think that electric vehicles means only motor. Today, in the market, at least we have 3-4 vehicles which are strong hybrid, in the sense that they have a motor which can also generate torque along with the engine. We have 3 vehicles, all from Japan. Very interesting, and they are quite successful. So ideally speaking, you could have 2 propulsion sources, one from the engine, the other from a battery. And there are different ways that you could get energy in the, electric energy. It could be if it's a plug-in hybrid, then you can get electric energy by, charging it from a socket. If it's a normal hybrid, then you can charge the battery also from the engine. So finally, the whole power comes from petrol, but a lot of advantage can be gained from that, and it's very surprising. I mean, when I saw the energy efficiency figures of, let us say, Honda City, which is a very successful sedan in India. If you compare the fuel economy with Honda City Hybrid, which has come into the market about 6 weeks to 2 months back, you will be amazed. The Honda City sedan has a fuel economy at the level of 17 kilometers. This is the ARAI figure, which is 17.6 or something like that. And the Honda City Hybrid, which also derives all energy from oil because it's not a plug-in hybrid, its fuel economy is of the order of 26, 27 kilometers. So there's a 60-70% increase in fuel economy, while the energy still comes from petrol. How does that happen? So there's a huge scope of energy management in the vehicle. That's the central point that I'm trying to make in this talk. All right, so look at electric vehicle markets. We hear them. You will see, if you see, that we are not selling too many. So although the sale is increasing and we hope to sell, and there is a lot of support, the government gives subsidy, but still the electric vehicle sales is around 5% of all vehicle sales in India. Only 5%. And that's also, mostly concentrated in the 2-wheeler, 3-wheeler areas. So the reasons are, there are reasons. We are not as rich that we can easily go and buy a Tesla. So this is a slide which I like to show. If you just compare two of the most, Tata Nexon is a very well-selling car from the Tata stables, and they have a Tata Nexon EV. So these are the same cars, so you can just compare them. They have the same dimensions, they have similar weights. The electric vehicle is slightly. So there are a couple of things you will see. So first you will see that they are roughly same drag coefficient, nearly same carb weight. Electric one is a little heavier because of the battery. First of all, you will see that the torque response is very high. So electric vehicles pull a lot of torque, and you can get a lot of quick acceleration if you want to, which gives you a thrill. Their mileage. This is Tata claims on paper that is 300 kilometer per full charge. I'm sure it's obtained, but it's obtained under very careful conditions, and you will not get it. You typically, by talking to users, I find that it's about 200. So, and the interesting thing is that the cost of the electric version is about 70% higher. So will you buy a car? So that's one of the biggest factors, but it is offset also by the fact that the running cost is very low. The cost of the battery, which is a 300 kilowatt hour battery roughly, or 30 kilowatt hour battery, I'm sorry, is somewhat, between 30 and 40% of the vehicle. It's about 6-7 lakhs, the battery itself. So now you have a 7 lakhs battery in your car, which grows old. You have to bother about insurance if you get into an accident. So these factors are important. So these factors worry the customer. But what I'm trying to say is that the economy of the electric vehicle today comes from the fact that it has a very low running cost, and therefore you will have to try to lower it further, and you will have to make the life longer. If you make the life longer, then it may make sense to buy an electric vehicle compared to a normal vehicle. That's what the research is trying to do. That's what I do in my research as well. All right, so this is a sort of restatement. I work with so this is a statement that one of my collaborators from Tata Motors says that in India, Sasta, Sundar and Tikau vehicles will sell. So it has to be reliable, it has to be cheap, and it has to be, Sundar means in performance, Sundar. But one of the reasons that we have is that, everybody talks about battery. If you see this battery, we have competency gaps in India in electric vehicles. We are trying to sell electric vehicles, but we cannot make battery cells. We can, almost all of the battery that we use, a very, very large percentage is actually imported. So we do not know how to make, we are going to probably learn because there are big factories coming up, but that's a competency gap. And there are other competency gaps as well. Car manufacturers typically depend on their tier 1 suppliers. So all the OEMs that you buy, they actually depend on other companies. For example, a Tata car will be having a Bosch controller. So the controller comes from another company, and that knowledge of control is mostly with them. So we have these gaps, and unless you bridge them, you cannot do energy management yourself. So that's something that we should look at in our research. And whenever you hear, people talking of electric vehicles, everybody talks about the motor and the battery. But I argue here that even if you have great motor and battery, that's not going to give you great fuel economy. You need great control. So just by having a great guitar, you cannot create good music. You have to play it well, right? So that playing is very important, and that's energy management. So the other thing which is interesting is that although where is the energy spent? Please tell me 5 minutes. When I have 5 minutes time, then I can. Otherwise, I have a tendency of I might overshoot. So it's interesting to note that although where do you spend the energy? You spend the energy in the car, of course, in the powertrain of the car. True. Torque, speed, efficiency. Product is energy integrated. But these factors, if you see, when you are bothered about how much energy I am going to spend when I am going from A to B, that's your problem as a customer. Then there are many things which affect this energy. So if you are an irritable driver, so I have seen how Ola drivers drive in Bangalore. Unbelievable. Because they have to take back 2,000 rupees, around 2,000 rupees home at the end of the day. If I compare it with, my driver, it's amazing. He doesn't bother at all. Whenever he needs petrol, he just looks at my face. So he drives in a totally different way. So you can actually end up spending a lot of more energy just by being an aggressive driver. Then there is terrain. So terrains are very important because our cities are having a lot of flyovers. You have to get up on those flyovers. You have to get down on the flyovers, right? And traffic. Traffic is extremely important because energy efficiency of cars depends on their torque speed characteristic. Where exactly are you operating? So you have to continuously choose good torque speed points to be able to spend less energy while going from A to B. And then there is, of course, the route. If you choose a long route, you are going to end up spending energy. So you see that it's not just the powertrain which determines energy. You have to see a lot of things. You have to see, including the cultural factor of driving that we have in our cities. All this determines energy, and when you consider it as a scale, it can actually spend a lot of energy. So I'll not go into this, but you can imagine that when you have an engine and a motor, and you are trying to balance energy, you need a certain torque. So you have to decide. The first thing you have to decide is how much torque from the motor and how much torque from the engine. So you constantly decide that looking at the operating characteristic of the engine and the motor. So you choose there are many operating points possible, as you can see there, to generate the same torque and speed at a certain gear setting, and you have to pick up the most energy efficient one without giving too many jerks to the passenger. That's essentially the job. So there's an algorithm which can do that, right? So this is the essence of energy management, that how much torque you want to drive your vehicle at, and of that torque, how much you want to generate from the motor, how much you want to generate from the engine. That is what finally leads to energy management. And so there is one question which is called the torque split question, that the total torque demanded, how to split them between the two sources. And the other is to decide that I have to go from A to B. So how much torque demand I need? Do I need to quickly move, then again brake? So if you are quickly moving, then you are requiring high torque. Then you are braking, only a part of that you can regenerate, everything you cannot regenerate. So if you are trying to go very fast, then you will probably, try to exploit every opportunity of going forward, and you will constantly give different torque set points. That's an aggressive driver. So there's a lot of energy saving that you can obtain by choosing what kind of torque set points you are going to give to the vehicle. And that can be optimized as well. But there are very interesting points. Today, I am submitting a project to the Department of Telecom for doing predictive analytics of batteries, which proposes to connect, let us say, 100,000 batteries traveling in 100,000 vehicles across the city, and they are all connected over 5G wireless to a cloud computing platform. So they are all continuously monitoring the battery. In fact, all Tata Nexon EVs, because Tata companies has launched this vehicle and they would like to know how the vehicle performs. So data is constantly coming. All vehicles are actually connected. That's not a problem at all. So I'm trying to say that, imagine that if you are going from A to B, you are asking this. Suppose you are asking this question. This question will arise in your mind multiple times. That first of all, can I reach from A to B? You don't know how much energy you have in your battery, right? So you may get stuck in the middle. So now this is the electrical range anxiety, and this will arise in the mind of the driver multiple times in a day if you are an electric vehicle driver. So how do you answer this question? That with the given energy, whether I can reach from A to B? This question is surprisingly difficult to answer. So the first question is, how much charge do I have? That itself is a very, 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 very surprising question. And then this charge is not, it's a complete misnomer. If you have seen batteries, you will know that the capacity of a battery is quite dependent on its discharge rate. So how much charge you have to deliver to the car really depends on how you are going to drive the car. So it's actually a coupled question. It's not an independent question that I have this much car, then this much torque. How much you have, that itself depends on how you are going to drive. And obviously how you are going to drive depends on how much you have. So it's actually a coupled question. Then the next question is that, how do you know how you are going to drive? How do you know from what? So suppose you are trying to go to Esplanade. How do you know what kind of traffic will happen 30 minutes later at the Ruby Junction? So you have to understand, you have to manage your battery and answer this electric range question. Much of it is in the future. So now, how do you accurately and scientifically answer this question? To be able to do that, you have to do prediction. So you have to do scientific prediction, and you need, first of all, probably using artificial intelligence machine learning. Now that requires data. So where will you get data? So now you have to connect all vehicles using a 5G wireless. So now you need 5G wireless. All this is just to enable you to decide whether with your charge you can reach from point A to B. So all these technologies are required, right? So this is a very interesting point to understand. So I'll skip the mathematics, but so let's talk about the battery a little bit. I mean, lithium-ion batteries are very expensive. They grow old. They have so much energy density that they're quite dangerous to operate. I made a battery pack, and I made the mistake of telling my assistant that why don't you take out the battery pack from. So after 10 minutes, I don't hear from him whether he has taken it out. So I called him. What happened? So he had he had a bunch of key in his pocket, and while lifting it, he dropped the key on the battery pack. Two connectors melted in less than 1 second, and there was an explosion. So and you have read about explosions. So lithium-ion batteries have to be very closely managed, both in terms of energy, also in terms of safety, also for lengthening their life. So the battery management system is very critical. Apart from many other things, there are. I talked to Niti Aayog and others about various policy meetings. So people are talking about battery as a service model. You actually buy a car without a battery. I mean, why should you buy the battery? You are not an expert. So you go somewhere and you rent a battery, and you use it for a few days. And when the battery charges, there go somewhere else. And just like you are getting petrol, can you swap batteries? So if you want to do these business models, then you have lots of other things for which you have to look very closely at the battery using a BMS. So these are advanced BMS technologies that we are looking at, but it's a part of battery management. So the BMS can create energy economy. It can create ownership value in terms of vehicle mobility. You won't get stranded on the road. It gives you reliability and safety. It can tell you whether there can be a fire. It can enhance useful life. It can give you various value-added services for the OEM, and it can enable different other business models which are going to come, right? Because we are talking about fleets. So Ola operates a large fleet of three-wheelers. So its business model is different. It says that come and rent the auto from me, drive it for a day. I will give you as much energy as you need. At the end of the day, return the auto with give me 1,000 rupees. That's a completely different business model. And if you have to operate it efficiently with energy economy, you need to manage the battery very well. So these are the advanced applications of batteries that are going to come. When you do battery management, you do it just like any complex management. You can do it at different time scales. So you can do at the instantaneous level of energy, which says how much charge you have. Then you can do it at a trip level energy management. Can you reach from point A to B? And then you can do it at a life cycle level where you say, am I going to need to replace the battery after 3 months? Because if your car is what's the insurance on the battery? The insurance on the battery of Nexon EV is 8 years or 160,000 kilometers, whichever occurs earlier. So 160,000 kilometers, first of all, some people drive cars beyond 8 years. Second thing is that 160,000 kilometers, depending on how you drive, you can easily spend it in, let us say, 5 years. So now you have a car and you need to change the battery, which is 6 lakhs. You cannot sell the car also because its resale value will fall, right? So lengthening the battery life over a long time is actually a very, very, very critical thing to do. So you have to do these energy economy over the life cycle, which is for a battery which is measured by the ampere hour throughput. That is, what is a battery? A battery basically takes energy for some time, holds it, and then gives energy. So it's like an intermediate object. So energy flows through it, and it grows old while taking energy, and it also grows old while giving energy. So if you have to characterize its life, you have to characterize its life in terms of its ampere hour throughput. How much charge has passed through the battery. So you can actually try to maximize the ampere hour throughput of the battery. So that's a battery management goal. Battery aging is also a very, very interesting thing. I mean, and not very well understood because batteries are very complicated electrochemical devices. I mean, in contrast to what we teach our undergraduate students, that it's a resistance with a series resistance, which we call the internal resistance. It's not like that at all. First of all, that value of the voltage comes down. Then the various kinds of impedance, all kinds of. It's a very complicated device. So and it grows old, and it's very critical to understand how it grows old. And there are various factors. So for example, two things happen. One of the things is that its capacity will fall. Today you have bought a 30 kilowatt hour battery. After 4 years, it will become a 20 kilowatt hour battery. Now the point is that at some point, it's not possible to use it in a vehicle because the vehicle is not designed for such a low battery. So therefore, you will typically automotive batteries are reduced around when their capacities fall to, let us say, 80% or 70%. But interestingly, in India, people obviously we don't have that much money, so people would like to stretch it. Can I use it for 60%? Can I use it for so people are going to try, right? And it's not bad. I mean, why should they suddenly replace the battery, especially when there is no second life? Where is the second life market? What is going to happen to all these lithium-ion batteries when they grow old? Where will it go? I mean, for the lead acid battery, there is a very standard recycling industry. Almost fully it is recycled. Where is that? Where is that for lithium ion? So it's not so easy to actually recycle. Therefore, you need a good second life, and one of the second life markets is actually stationary energy storage. But you have to remember that if you put second life energy as a second life energy storage, you are actually operating the battery in that part of the curve. So its capacity is fast falling. So you will have to have a strategy of monitoring it constantly upgrading the battery. So now it is neither a fixed cost nor a variable cost. It's somewhere in the middle. So all these things will arise when you try to take put let's say automotive batteries and then put them into a let's say a building. So so therefore it is very important to actually track batteries age and capacity. So that's another very important thing. So what I'm trying to tell you is that to get value out of a car, of an electric vehicle today, apart from other factors, there are also other factors. For example, charging infrastructure. So charging infrastructure is a problem that is going to come up. That is again related to the power systems people, because what about distribution? Once I went to Barcelona, people said big problem. In summer, in the morning, everybody's on the beach. In the evening, everybody's in the city center. So the load shifts around in the city. If you have a big basketball match in the US, huge load there. Other times, no load. So this load shifting can create a lot of challenge to the distribution authorities. But anyway, let's. I think our 20 minutes is more or less done. So you.
Sir, you finish whatever you have to say.
Thank you. So the last thing that I want to mention is that it's very interesting. Particularly, I mean, I can discuss this for 2 minutes in this crowd because we are all electrical engineers, mostly many mechanical engineers also. But the fact that batteries are generally series connection of cells. When you have a series connection of cells, just like a chain, the strength of the string is actually decided by the weakest element in that chain. So what is going to happen is that when you are going to start out with a with a new battery, all of them are almost equally strong because they have come from the same manufacturer, they're all new, etc. But they have some manufacturing problems, and then they live through a different thermal history. It depends on how the pack is constructed. Sometimes air is flowing on the battery. So if air is flowing on the battery, this cell is always experiencing air at let us say 3 degrees centigrade more than this cell because air is flowing this way. So the thermal history of this battery and this battery are different, and therefore they will age differently. So now in a string, you are going to have a number of cells which have aged differently, which means that now their capacities are different. So when you charge them using a series current, their state of charge and voltages some will quickly reach high, some will slow. So you see now, and when the voltage reaches high, you will have to stop because you cannot overcharge any cell. So now, because even if there are other cells which have capacity, you are not using it. Such an expensive thing. So you have to have a mechanism of shifting charge from this and then bring it to the other cells. So you have to have a circuit for charge balancing. If you don't do charge balancing, then you number one, do not use the full capacity of the battery, and you also endanger its life. So this is also very important. Today most BMSs do not have active charge balancing, they have passive charge balancing, which is very slow process, limits, because there are other issues. So I'm just mentioning the problems to you to say that to make a car price effective for an Indian customer is actually a humongous technical problem. And it's very interesting, very interdisciplinary, and we should work on it. As a researcher, I am delighted. As a customer, I am not. So this is my last slide. So I think it's always good to build a better battery or a better motor. Fine, always. By the way, we have big competency gaps even for motors because automotive motors are not the same motors. We have got the delivery of our first designed automotive motor this week. So they look different. Their whole design is different. So even if you have that, it's very important that given a battery and given a powertrain, you operate it well. That can give you 15, 20, 30, 40% advantage, as we have seen from these two cars, right? The cars which are on the market. And energy costs arise from a choice of operating point. So you need to constantly, automatically, algorithmically choose these operating points. And it happens because you have some degrees of freedom. You can optimize only when you have options. So you have to create propulsion options, and having two propulsion sources does exactly that. And then battery life cycle management is actually critical for XEVs. And there are many things which are not in place, and there are lots of things that we need to do. And these will, it's very appropriate for a power company to understand these, because these are all related to our distribution. So that's about it. I love to say this, that we did it in space and we can do on the road too. We can do a lot of things. It depends on what you focus, and this is probably something worth focusing. Thank you very much.